Good morning, students. Today we are going to start with chapter 10, that is light, of 10th class physics. In these slides, we are going to learn about light, luminous and non-luminous objects, what is ray, what is beam, characteristics of light, and then we will be talking about the reflection of light, regular and irregular reflections, and later in these slides we will talk about the spherical mirrors and terms which are related to spherical mirrors. Yes, students, let us start with an example. Say you are entering a room, a dark room. Will you be able to see the things around you? I suppose the answer is no. Now, if you turn your flashlight of your cell phone on or lit a candle, then you will be able to see the things which are there in that room. This is because the light from your phone or from the candle, it falls on the substances or the things which are around you, and then it bounces back, comes to your eyes, and your eyes catches those light or rays of light, and it enters into your eye lens, and hence an image is formed at the retina of your eye, and then these electrical signals are sent to the brain interprets it, and hence you are able to see the things. So you can see the things with the help of light. So what is light? Light is an electromagnetic wave which possesses energy, and it produces sensation of vision. Hence, with the help of light, you can see the things around you. Let us talk about luminous and non-luminous objects. The objects which are sources of light themselves, that means the objects which themselves are sources of light or emit light, they are known as luminous object. Example is sun. Sun is a huge source of energy and it emits huge amount of light. Candle emits light. Electric bulb is one of the example of light. You must have heard about firefly, that is Jugnu. Jugnu is also a luminous body. So the objects which emits light, they are known as luminous object. Non-luminous objects are the objects which do not emit light, but when light falls on them, they are visible to us. Hence, the example for the luminous object or luminous body is moon, earth, table, chair, pen, pencils around us. Let us talk about the terms which are related to light. The first term which is related to light is ray. A straight line path along which the light travels is known as a ray. Here you can see we have drawn a ray which is represented by an arrowhead. So this is the example of a ray, a straight line path along which the light travels. Beam is a bundle of rays. So here you can see the second example, parallel beam, where there are number of rays in a parallel way. Another one is divergent beam, where you can see that from one point light is being diverged at different parts. So this is divergent beam. Another one is convergent beam, where rays of light are seen to be converging at one point, are seems to be meeting at one point. That is convergent beam. A flashlight is shown to you. In this flashlight, you can see the rays are coming out of the flashlight. That means this stands for a beam of light. In this slide, we talk about the characteristics of light. The first characteristic of light is that light is a transverse wave. You're going to understand about waves and types of waves in the chapter of sound later. So for the time being, just understand that light is a transverse wave where the particles of light will be traveling perpendicular to the propagation of waves. It does not need any medium to travel. You might have seen that the light coming from sun comes on earth, and in between sun and earth there is no medium. Even then we can see the light coming on the surface of earth, right, reaching on the surface of earth. Hence it does not need any medium to travel. Speed of light is different in different materials. Here, speed of light in vacuum is supposed to be 3 into 10 raised to power 8 meter per second. In air, it is 2.25 into 10 raised to power 8 meter per second. And in glass, it is 2 into 10 raised to power 8 meter per second. Light gets reflected when it falls on a polished surface like mirror, and hence you are able to see your reflection in the plane mirror because the light is getting reflected, or light is bouncing back when it falls on a surface. So light has a property of reflection. Light undergoes refraction as well. Now this is a property when light enters from one medium to another medium. For example, light entering from air to water. It gives another property that is known as refraction of light. You might have seen bending of light. The example of a refraction is if you have a glass full of water and you put a pencil in that glass full of water and see that glass from a distance, you will see that pencil seems to be broken at one point at the interface. That part when light passes from one medium, from air to water, it seems to bend toward one side. That is known as refraction of light. This is a slide about reflection of light. The definition of reflection is bouncing back of light after it is incident on a surface. So the phenomena of bouncing back of light after it is incident on a surface is known as reflection of light. Here is one of the example. A ray is given to you. This is mirror. This surface is mirror. There is a ray which is incident on mirror. So this ray is known as incident ray. When this ray is incident on a mirror, it bounces back, and the ray which is bouncing back is known as a reflected ray. So incident ray and reflected ray, these are the two rays. Then we have another part which is known as normal. Normal is the perpendicular drawn to the given surface. So here this is the interface and this one is normal drawn. So you have incident ray, reflected ray and normal. So the phenomena of bouncing back of light after it is incident on a surface is known as reflection of light. Now, the angle made by the incident ray with the normal is known as angle of incidence, and the angle made by the reflected ray with the normal is known as angle of reflection. We are going to study about laws of reflection. So the first law of reflection is that angle of incidence is always equal to angle of reflection. So here you can see this is angle of incidence and this one is angle of reflection. So first law states that angle of incidence is equal to angle of reflection. Second law of reflection is that the incident ray, normal and reflected ray all lies on the same plane. You can see over here, this is your interface and all these rays, incident ray, reflected ray and normal, they lies on the same plane. Reflection can further be divided into two parts, regular reflection and irregular reflection. In case of regular reflection, the incident rays which fall on a smooth surface will be reflected back or will be bounced back in a parallel fashion or in a regular fashion. So these reflections are known as regular reflection. Now, in irregular reflection, the reflection of light from a rough surface or irregular surface takes place in a random manner. You can see here that the incident rays, when these rays are falling on a rough surface or a bit irregular surface, they are bouncing back in different directions. Hence, this type of reflection, when the reflection of light takes place on rough or irregular surface, this reflection is known as irregular reflection or diffused reflection. Dear students, you must have come across these types of spherical mirrors when you visit a shopping center, an airport, going to a mall, or visiting a cinema hall, or through a subway, you might have seen these types of spherical mirrors. So in the next slide, we are going to talk about these kind of spherical mirror whose reflecting surface is a part of a hollow sphere of a glass is known as spherical mirror. Students, imagine a huge spherical ball made up of glass. Now, what we are going to do with this huge spherical ball made up of glass? We're going to cut a small piece of this spherical ball from the right hand side. And then that piece is being polished from the outer surface. So let us think about a huge ball, and this is a piece of that ball which is being cut from the right hand side and is polished from the outer surface. So what happens? The inner surface of this glass becomes the reflecting surface and the outer surface of this piece becomes the polished surface. Now, this whole thing will act as a mirror. What type of mirror? Concave mirror. So, a concave mirror is a mirror in which the reflection takes place at the inner surface and the outer surface is polished. So when the rays are coming or are incident on the inner surface of this mirror, these rays will be reflected or they will be bouncing back through the inner surface. So this type of mirror is known as concave mirror. Again, in this concave mirror, the reflection takes place at the inner surface and the outer surface is polished one. Now, again imagine that huge spherical ball of glass and cut the left hand side of it, a small piece of that glass. Now paint the inner side of that glass, polish it. Now, if we polish the inner surface, the outer surface becomes reflecting surface. Now, when the rays of light fall on it, they will bounce back. So, this type of mirror is known as convex mirror, in which reflection takes place at the outer surface and the inner surface is polished. So, upper part is an example of concave mirror and the lower diagram is an example of convex mirror. In this slide, we are going to discuss about the terms which are related to the mirrors. So the first term is pole. Pole is the midpoint of a mirror, whether it is a concave mirror or a convex mirror. Midpoint of a mirror is known as a pole. Midpoint of a concave mirror or midpoint of a convex mirror is known as a pole. Second term is center of curvature. As we did in the beginning, we took a whole sphere which was made up of ball. So if we take the center of that spherical ball of glass, the center of that spherical ball of glass is known as center of curvature. Okay, so here this center is the center of a spherical ball whose this mirror is a part of. So center of curvature is defined as center of a sphere whose this mirror is a part of. Next term is radius of curvature. Now the distance between the pole and center of curvature is known as radius of curvature. Distance between pole and center of curvature is known as radius of curvature. Now we have understood what pole is and what center of curvature is. If we use an imaginary line which passes through center of curvature and pole, this imaginary line is known as principal axis. So an imaginary line passing through the pole and optical center is known as principal axis. Now to understand focus and focal length, we have to draw the diagram first. Let us start with concave mirror diagram, then we'll be moving to convex mirror diagram. So here is concave mirror. Draw this concave mirror and draw the terms pole, center of curvature and principal axis. So this is your principal axis which is passing through center of curvature and pole. Now we need to draw some parallel lines parallel to the principal axis. So let us say here is one of the line which is parallel to the principal axis. At this point, when it strikes at the surface of the concave mirror, reflection will take place. So this ray will be reflected in this direction. In the same way, another ray which is parallel to the principal axis, after reflection, it will go in this direction. You can see these reflected rays are meeting at one point. This point where the reflected rays meet after the reflection take place is known as focus. Now, wherever these rays are meeting after reflection, that is also known as convergence in case of concave mirror. Now, let us talk about the convex mirror. Here, the diagram of convex mirror is shown to you. This is a convex mirror whose inner part is polished one and outer part is reflecting surface. And then you have a center of curvature here and pole. Now draw a line which is passing through the pole and center of curvature, which will be principal axis. Now we need to draw parallel lines, that means parallel to the principal axis. Now say one line we have drawn parallel to the principal axis, that is your incident ray. Now when incident ray is meeting at the surface of the convex mirror, reflection will take place. Now in convex mirror, reflection will take place in this direction. What you have to do is, you have to extend this ray in the backward direction with the help of your pencil and scale. Other ray which is incident on the convex mirror will also be reflected back in this direction. So this ray also has to be extended in the backward direction. Now, wherever these rays are meeting, this point is known as focus of that mirror. So in this case, focus of convex mirror is this point. Now, this is a point where you can see that the divergence of rays is taking place. So in case of concave mirror, convergence takes place, and in case of convex mirror, divergence takes place. Hence, according to the definition of focus, it is a point where light rays parallel to the principal axis will converge or diverge after reflecting from the mirror. So, focus is a point where the rays meet after reflection in case of concave mirror, and focus is a point where rays appears to meet after reflection in case of convex mirror. Next term is focal length. Now focal length is the distance between the pole and the focus. So this distance between the pole and the focus is known as focal length. Here also the distance between focus and pole is known as focal length. The main and very important term here is aperture. Aperture is a point from which the reflection of light actually happens. So in this case, whatever is the coverage area of the mirror, that whole area where reflection can take place is known as aperture of a mirror. So students, draw the diagram of concave and convex mirror in your fair notebook. Also label the diagram with pole, center of curvature, focus, principal axis. Please keep in mind that the distance between pole and focus, and then focus and center of curvature, must remain same, which means that the radius is equal to 2 times the focal length.